All right, everyone. Welcome back. So we're just going to dive right into practice test 3. And we'll head to the math. Now, as always, is there any question in particular that anyone wants to go over? We're going to start with the no calc. And unless there's anything in particular, we'll just run our way through. There's going to be a few questions we skip. There's a few questions on this particular test that they're just, they haven't asked anything like it since this, and this is like the oldest test. Well, it's one of the oldest tests, and they just haven't asked anything like it since then. All right, so if no one has any special requests, we'll just start working our way through. So a painter will paint N walls with the same size and shape. Ooh, do we have a request? You're going to need to be more specific than the word algebra. I'm not sure what you mean. All right, we'll get back to that. All right, yeah, we'll definitely get to some graphing questions as we go. There's a lot of them. So we'll definitely get there just in the normal course of activities. All right, so a painter will paint N walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression NKLH, where N is the number of walls. If the student asked the painter to use a more expensive brand of paint, which one would change? Okay, this is a really weird question. Not very hard, but so basically it's asking which one of these would change. So it says K is a constant. So so yeah, here, if you take a look at this, now it says N is the number of walls, L is the length of the wall, and H is the height of each wall. Now, in the original equation, it was a given that we were using a specific brand of paint, which is why K was the constant. Now, it says K is a constant with units of dollars per square foot. Now, while it doesn't like explicitly say that that's related to the brand of paint, all of the others definitely are not. And this is actually like, it makes sense that this is related to the brand. This is related to the fixed cost of the paint. The answer there is C. And what do we have? I do not know what page it is in your textbook. It should be towards the end. This is practice test 3 was your homework, correct? I believe that's what Anthony emailed out. Yes, this was your homework. Yeah, right. It said practice test 3 was the homework. Basically, this should be the second to last test in your blue book. All right, number 2. If 3r is equal to 18, what is the value for 6r plus 3? All right, well, so this is just straightforward algebra. Let's just solve for r. So 3r is equal to 18. We'll just divide both sides by 3. R is equal to 6. Now let's take that 6 and plug it back in. Note as a trap answer, the intermediate step there. So 36 plus 3, 39. Moving right along. All right, so which of the following is equal to a to the 2/3 for all value of a? So now this is one of our exponent questions. They've moved away from these a little bit, but to the extent that these can get a little hard, this is the rule that like people don't tend to know. So just blazing our way through these real quick. x squared times x to the third is x to the fifth. When you multiply similar bases, you add exponents. X to the 10th divided by x to the 7th is x to the third. When you divide, you subtract exponents. X to the third to the fourth is x to the 12th. When you raise one to another, you multiply. All right, so now here are the two that people tend to get tripped up on. So one, if let's say you have x to the negative third, if you have an negative exponent, the way you resolve it is you change the exponent from either the numerator to the denominator, or if it started out in the denominator, you bring it up to the numerator. So for example, this would become 1 over x to the third. Now though, if you had 1 over x to the negative third, well, then that would just become x to the third. You just flip wherever it is. Now, this is testing the last one. All you do with this is basically this becomes the third root of a squared. It becomes the denominator root of a squared. Now, yeah, so that's what's going on there. So our answer is D. The number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. If 30 states joined between 1776 and 1849, and X states joined between 1850 and 1900, which of the following equations is true? Okay, let's take a look back. A number of states joined. So the number of states that joined in those years is twice the number of states that joined in those years. So let's call those, all right, it's calling those X, right? So this range is 2X. 30 states. All right, I see what's going on here. So basically, what's going on is we have double the amount of states joining in this range. Sorry, we have double the amount, the number of states that joined the United States between this range is twice the number of states that joined in that range. So this is the one that's supposed to be bigger. If 30 states joined in this and X states joined in this. So we also know that this range is 30, right? So basically that gets us here. Because what do we know here? We know that, trying to think how to explain this. So if you take it one step at a time, the number of states that joined the United States between 1776 and 1849, right? So that number of states is twice the number that did this. Then it said this is 30, right? And 30 is also twice the number that did that. So just if you do X divided by 2, that'll equal 30. No, that's absolutely not right. My apologies. It's that one. Sorry about that. My apologies. If you do this, the number of states that joined from those years is twice the number of those years. So effectively, we know that means 15 joined during those years. But so we know X, this is basically just telling us X is 30, right? So, and we know 2X equal to 30, X is equal to 15. Sorry, yeah. Moving right along. If 5 over X is equal to 15 over X plus 20, what is the value of X divided by 5? All right, so what's the path of least resistance on this? The path of least resistance on this is to just do the algebra. All you need to do here is cross multiply and solve. So we would get 5X plus 100, right? Because we'd multiply both sides by X plus 20, cancel out there. And then that would be equal to 15X. I don't know why I wrote 1,000 plus 100. 10X is equal to, so we subtract 5X from both sides. 10X is equal to 100. x is equal to 10. So our answer would be, well, not our answer, x is 10, but then we have to remember, oh, and there's our trap answer conveniently located at A. Then we have to remember, okay, it's actually asking us what is the value of x divided by 5. Well, 10 divided by 5, that's 2. They're trying to get you with that little extra step trap. All right, so here we have a systems question. If x comma y is the solution to the systems of equations above, what is the value of x minus y? So there's actually a little trick here that you can do. So do you see how this is asking you for x minus y? Now you could solve for x, and you could solve for x individually and y individually. Or for this particular one, and you'll see this, they kind of like doing this when they give you an expression as opposed to like, please solve for x. But if you actually just add these together, you'll have 5x minus 5y is equal to negative 20, right? Well, if we just divide everything by 5, we have x minus y is equal to negative 4, right? You didn't even need to solve for one or the other on this particular one because of the way it was set up. Now, the reason why I knew to look at it that way is they do this. Like, this is something that they'll do from time to time. Now, you would also always get it right if you just, ran the math, but it's a little bit more. And when I say run the math, I mean, you would have to multiply this by, multiply this by 3, multiply this by 2. So then you have 6x for both. You cancel x out and then you deal with the y's. But this way is faster for this particular question. By the way, does anyone have any questions on anything I've gone over so far? I feel like I'm going fast. Okay. In that case, all right, so here's a 7. So here you're dealing with what is in effect an XY chart, right? Whenever you see an f of x chart, it's xy. Basically, there is some function going on, and each one of these represents a point on that function. Now, this tells us it's a polynomial, not a line. Some values of x and f of x are shown. Which of the following must be a factor of f of x? So here's what's going on, right? Now, where this is throwing in, so this is a polynomial. It doesn't actually tell us what it looks like, but this is a polynomial, right? This is a parabola. This would be an x squared plus or minus whatever. Well, if I asked you what the factors of that were, well, that's just the x-intercepts, right? That's just when y is 0, right? Like we'd get a factored form of x minus, something times x minus something else, right? So here, it's the same concept. They're just presenting it like in a little bit of a confusing way. If you have a factor of a polynomial is just where it hits 0. So here we know, all right, and by the way, I like to literally do this. When I see one of these, I'm just like XY. I don't want to forget what's what later on. Just put yourself on autopilot. I like to offload as much thinking as possible by just writing on the page. So here we have, right? So here we know when y is 0, x is 4. So x minus 4 is a factor. Boom. All right. So here we have a line question. The line y is equal to kx plus 4, where k is a constant. All right, so basically, this is y is equal to mx plus b. They're saying k is a constant. In this particular case, it's a slope. If that is graphed in the xy plane, if the line contains this point, what is the slope in terms of c and d? So this is a whole lot of words that just mean, hey, plug in c and d, right? Because if we have our y is equal to mx plus b form, right? M is the slope. B is the y-intercept. B is the x-intercept. Y-intercept. And then xy represents any point on that line, right? So if you have a coordinate pair, you can just sub it in for x and y, right? Now, this is not a problem since it's asking you to just leave everything in terms of the variables. So let's just start out by plugging in C comma D, all right? So y is equal to kx, all right, so that's x, that's y. So D is equal to cx plus 4, right? I just plugged that in for x and that in for y. Oops, nope. D is equal to kc plus 4. All right, well, then we just simplify this so we're solving for k, because k, the variable attached to the constant attached to the x, rather, that's your slope. So that's why we know k is the slope. So d minus 4 divided by c is equal to k, and that is a. All right, anyone have any questions on anything we've covered so far? All right, moving right along. In the system of equations above, k is a constant and x and y are variables. All right, so here we have a system. They're being a little cute by having one of the coefficients be a variable. For what value of k will the system of equations have no solution? All right, so we have two lines and we're asking about no solutions. Do you guys remember what that means? It's a game they like playing. All right, no solutions means the lines are parallel. So if we take these and stick them into y is equal to mx plus b form, it will have no solutions when the slope is the same, right? So let's give that a shot, right? So I'm just going to convert these into y is equal to mx plus b form. So negative 3y is equal to negative kx plus 4. Y is equal to k divided by 3, x minus 4. All right, so that's one of our equations. Nope, minus 4 over 3. And then our other equation would be negative 5y. Negative 5y is equal to negative 4x plus 7. Y is equal to 4/5 x minus 7 over 5. Now, all right, so we know if they're, now it's asking us when the lines are going to be parallel, right? Well, so they're parallel when the slopes are the same, right? So all we need to do is take this slope, 4 over 5, and set it equal to that slope, k over 3, right? So 4/5 is equal to k over 3. K is equal to 12/5. So our answer is A. Now, a few things to note with this. One, let's say they had asked for infinite solutions. Now, you can't actually turn this one into infinite solutions, but infinite solutions would be if we had the same slope and this value was also the same. Infinite solutions is, again, I know we discussed this last week, but I really like to remind everyone, infinite solutions is when you have that situation where you have two lines that are the same. It'll typically look like, like 3x plus 4y is equal to 4, and then 6x plus 8y is equal to 8. These are the exact same line. You would have infinite solutions, right? Infinite solutions being graphed and looking like this. Any questions? All right. In the xy plane, the parabola with equation y is equal to x minus 11 squared intersects the line with the equation y is equal to 25 at 2 points, A and B. What is the length of AB? All right, so effectively what we need to do here is we just find, so basically we have these two lines, right? We have x minus 11, and then we have y is equal to 25. Now it's asking us what's the length of from there to there. Well, how would we figure out the length from there to there? Well, if we figure out this x coordinate, and this x coordinate, well, then it's just the difference, right? So how do we figure those out? Well, actually, all we need to do is set these equal, right? Because if we set the two equations equal, what we are solving for is the point of intersection. Now, here's another strategy. It's not one the College Board particularly likes, but it works. Let's say you had no idea what I just said, right? You're like, I don't understand anything. Well, like, setting them equal is really the only thing that like jumps out as being what you can do. I really do emphasize, if you don't know what you're doing to solve a problem, just start doing whatever you think you can do, and a lot of times it'll just fall into place. So here, though, it would be 25 is equal to x minus 11 squared, right? 5 is equal to, well, plus or minus 5, is equal to x minus 11. X is equal to, x is equal to 16, and x is equal to 6. So, all right. So, and by the way, the reason why I got plus or minus over here is that I took, when you, that's what happens when you take, like, we know we need two solutions. Well, when you take the square root of something squared, it becomes plus or minus on the other side. Because if you think about it here, what the x value that gets us negative, the x values of 16, right? Well, 16 minus 11 is 5. 5 squared is 25. Or 6, because that'll get us to negative 5 squared, which is also 25. So when you take the square root of like a squared term with the x in it, you have to plus or minus the other side. So our x values are 6 and 16. So the difference between those is 10. Huzzah. Anyone have any particular question here that they want to go over? So I can just keep going. All right. In the figure above, lines K, L, and M intersect at a point. If x plus y, so if these two are equal to u plus w, those two, which of the following must be true? All right, so we have a few varieties of things going on here. So let's just start checking these. Is x equal to z? So, all right, here's the thing. So, all right, see, so if x, y, and wu are the same, right? Well, let's break down those in constituent parts, right? So do we know vertical angles? Hopefully we know vertical angles. But since y and u are created by the same lines and they're across from each other, we know that those are equal. Well, if x, y, and wu are equal, that means x and w are equal. Now, z is a vertical angle of w. So z is equal to w, which is also equal to x. So so 1 is a factually accurate statement, which means we can get rid of c. All right. Now let's check 2, y and w. So if we take a look here, there is no particular rule that lets us establish that. Like, I don't know, they could be equal, but there certainly isn't a rule that says they're equal. Because y is equal to u, and while we know that this is equal to this, we don't know. Basically, we know x, w, z, and t are equal, right? Because we know x is equal to w. These are vertical angles of those. So all of those are equal. And then we know y is equal to u. But that's all we know. And then 3, z is equal to t. Okay, well, that's the same thing, right? W is the vertical, z is the vertical angle of w, t is the vertical angle of x. So we know that's accurate. So the answer here is B, 1 and 3. So it's kind of hard to explain. There just is no rule. Like in terms of ruling out two, there just isn't a rule that would let us know that those are equal. It's not that they can be definitively proven that they're unequal. There's no rule saying they are. Because then that's why it says must be true, not could be true. Anyone have any questions? In the quadratic equation above, A is a non-zero constant. Okay, so this is going to be our vertical stretch or shrink, plus or minus is up, down. The graph of the equation in the xy plane is a parabola with vertex C, comma D. Which of the following is equal to D? Okay, so it's telling us that the vertex, the graph and the coordinate, the graph of the equation. All right, so basically what is it telling us? It's telling us that this is our vertex. And then it's asking us which of the following is equal to D. So that's our X, and that's our Y. Okay, so here's kind of how we build this backwards. All right, so this is kind of an interesting question. There's a little work to be done here because we're going to need to build this backwards. Now, so I'm just going to point out a few things. One, I can actually tell you what the vertex is here, right? If I look at this, I can just flat tell you the vertex of this because I know the x-intercepts. And the x-intercepts of a parabola, if you split them right down the middle, that's the vertex. Parabolas are symmetrical. So what are my x-intercepts here? My x-intercepts are 2 and -4, right? Because x is equal to 2, x is equal to -4. That would both be when they're 0, right? Those are where they would cross that line. So, well, then what is the vertex? So the vertex is just going to be, the vertex would be -2. Nope, sorry. 2 minus 4 divided by 2, which is equal to -2, -1, right? So the x value for our vertex is -1, right? Now it's just asking us what's the y value of our vertex. By the way, did everyone just follow what I did? Was I clear on how you find, how when you're in the x-intercept form, you find the vertex, right? So just in case I wasn't clear, but basically here's the idea, right? If I have 2 x-intercepts, parabolas are symmetrical, right? So if I have my x-intercepts, if I just split the difference, okay, my drawing's horrible, but just to pretend that that was the vertex, if I split the difference of my x-intercepts, that's going to be the vertex. They're symmetrical. And that actually works with any 2 points on the same, that works actually with any 2 points on the parabola on the same thing. Like, let's say they were like, okay, this is 25 and solve for those. If you split the difference on those, it would actually also work out the same. So which of the following is equal to D? Well, we just established, like I said, 2 minus 4, -2 divided by 2, because we're averaging them, -1, right? So now if I plug in -1 for x, right? So C, we know C is equal to -1. Like we're just able to solve for the value of C. Now, if I plug in that -1 for x, we get -1 minus 2 times 1, -1 plus 4, -3 times 3, -9, right? So then we have -9. This all resolves to -9a. So the answer is A, -9a. Does anyone have any questions on what we just did? Great. Now, also, just to quickly review, if you remember, now there's also a really quick and easy way of finding the x coordinate of the vertex from standard form being ax squared plus bx plus c, right? If you just do negative b over 2a, that is also the x coordinate of the vertex. And then you can always just find the y coordinate by taking the x coordinate and plugging it back in. Moving right along. Ooh, this one, fun. This is part of that. All right, so this is not a hard question. It's just very, very work intensive. And you have to remember that concept that I taught you earlier, where it's just that, that concept I taught you earlier, where when you have two things, like when you have two polynomials that have all of the same degrees and they're equal to each other, the coefficients have to be the same, right? So in effect, what you would do here is you need to start out with this. By the way, so like, again, let's say you have no idea what you're doing. Well, it's like, okay, well, I see ax minus 2 here and ax minus 2 there. Like, let's just try getting rid of the denominators and seeing what happens. All right. So in effect, what we'd be starting out with is we would have negative 8x minus 3 minus 53 ax minus 2, right? Now we'd be multiplying this whole side by ax minus 2, right? So that drops out, but now we have to resolve this, right? So what would we get? We would get negative 8ax squared minus 16x. So actually, by the way, we can literally just stop here and solve it. I just want to, yeah, you know what? That's a better use of our time. We're just going to stop here because we can solve it from here. Now, if this was a harder question, you'd have to like finish distributing it all out, right? However, because this is the only x term on this side, this will be the only x squared term, right? If you resolve the rest of the math out here, you're going to have, a lot of other things that needed to be added together. But we know that because this is where x is, and that's the only place where x is where we're multiplying, that will be the only x squared term, right? Well, so on this side, the only x squared term is 24x squared, right? Now, if it's true that these equations are equal, the coefficient attached to x squared on both sides needs to be the same. So what do we know? We know 24 is equal to negative 8a, right? Little division, a is equal to negative 3b. Now, that is a question that looks like an absolute nightmare. That is really not that bad if you get what's going on. So, but what's the key concept there? If you have two polynomials and they are equal to each other, the coefficients attached to each degree of that polynomial, like degree, x squared, x, whatever, they must be the same. Okay, great. Does anyone have any questions on anything? Am I going too fast for you guys? Going too slow? All right. So, all right. It baffles me why this one is as far into the test as it is, but let's just do it. So, all right, we can already tell, like, product sum is not what you're going to be doing here, even when you glance at the answer choices, because there's roots. But it's just asking you what are the solutions to this, right? Well, okay, all we need to do is plug it into the quadratic formula. Now, if you plugged this straight into the quadratic formula, like, yes, you get the answer, but you'd be doing a lot of unnecessary work. The first thing I would do here is I would just divide everything by 3, right? Let's just get that a to be, let's just get that a to be 1. So x squared plus 4x plus 2 is equal to 0, right? So now the quadratic, by the way, I'm not going to show you how to complete the square because we have limited time. However, if you do know how to complete the square, completing the square is faster. But it would require a bunch of practice, and if you know the quadratic formula, you know enough to kind of do all the stuff anyway. Negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a, right? So negative b, negative 4, plus or minus the square root of b squared, 16, minus 4 times a, so 4 times 1 times 2, so 16 minus 8, the whole thing over 2, negative 4 over 2 plus or minus root 8 over 2. Now, what you have to be able to do is you have to be able to simplify root 8. So the way you simplify root 8 is you break that out into root 4 times root 2. And that becomes 2 root 2. So now we have negative 4 over 2 plus or minus 2 root 2 over 2, which just simplifies to negative 2 plus or minus the square root of 2, which is a. Right? Anyone have any questions on that? All right. All right, so let's take a look at this. Now, this is an example of one of those ones where it's how do I put this? This is an example of one of those ones where it's just how do you read the line, right? So how do you conceptualize this thing? So in the equation above, it shows how a temperature F measured in degrees Fahrenheit relates to a temperature C in degrees Celsius. Based on the equation, which of the following must be true, right? So this is kind of in y is equal to mx plus b form. I'm going to play with it a little just for the sake of conceptuality, or rather simplifying it. So c would be equal to 5/9 f minus 32 times 5/9. Right? I'm just going to distribute that out. So if you remember, what does this mean? This means that negative 32 times 5/9, that is our y-intercept, or that is our initial value, right? Now, what does 5/9 represent? What 5/9 represents is how much, that is the change in degrees Celsius per 1 degree Fahrenheit. And this is one of those, like, you know, like if you take a look, if this is a 15, this is one of those like hard ones. Well, I don't need to use hard in quotes. This is actually a hard question for most people. This is one of those ones that if you conceptualize it the way we've been talking about, it actually really simplifies it, right? So, but remember, so C, so 5/9 is the slope. 5/9 is the change in Celsius per 1 degree Fahrenheit, right? So it says, all right, so now based on the equation, which of the following must be true? A temperature increase of 1 degree Fahrenheit, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Yeah, so that is the amount, that's literally what we said, right? 5/9 is the change in Celsius per 1 degree Fahrenheit. This says the temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of that, right? Yeah, so we're already done with that part, right? Now, we don't even need to worry about 3 because we know 1 is true, right? Now it says a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit, right? Okay, well, let's evaluate this, right? Well, in order to go up 1 degree Celsius, right, this would have to produce 1, right? So, well, guess what? If we multiply 5/9 times 9/5, that is what would get us 1, right? So if F goes up by 9/5, then yeah, that does produce a 1 degree increase, right? And another way of saying 9/5, 1/8. So our answer is D. But this is like one of those ones where I really want to emphasize. It's that way of conceptualizing it that really helps that like just like cut through. Does anyone have any questions on any of those? All right. By the way, so I've, for the person who wanted to talk about lines, I'm just going to run through this one concept very quickly. It's a line concept. They asked it, no joke, like 5 times on the March test. Whenever you're dealing with lines, you're dealing with graphs and tables and charts, right? Like if you have a chart that's literally just like, any chart that's, they could say X, F of X. It could be like watering, the amount of water versus height. Anything like that with a chart or even just on a graph. Where that is our X value and that is our Y value, right? Let's say that was a scatter plot. What you can always do with these to figure out the slope and to build the line is take 2 data points. And for the purposes of this, right, like you can treat any of the, like if it's a scatter plot, you can treat any of those points as your data point. Or if it's a table, you can just take 2 entries on the table, like 2, 4, and 3, 8, right? Second, it's not actually linear, but like let's say we had 2, 4, 3, 8, and it would be 1, 0, right? We could take any 2 of these and treat that as a data point, right? So let's take our data points. So if we picked 2, 4, and by the way, does anyone have a burning desire to go over anything 16 through 20? Because otherwise I'm just going to explain this. All right, so 2, 4, and 3, 8, right? We've selected those from the table as our data points. Here is how you build the line, and please, please, please know this. Here's how you build the line. So first thing you do, you find the slope. So that's change in Y over change in X. So 8 minus 4 over 3 minus 2. That would be 4 over 1. So our slope is 4, right? Now that we have our slope, I'll do Y is equal to 4X plus B, right? Now we can take any data point because all XY represents is a point on that line. So we can take any of our data points and just plug it right back into the line. So let's go with 2, 4. So that's our X value and that's our Y value. So we take our X value and we plug it in there. We take our Y value and we plug it in there. We would then have 4 is equal to 4 times 2 plus B. So then we would have 4 is equal to 8 plus B. B is equal to -4. So our line would be Y is equal to Y is equal to 4X minus 4. That process, you got to know that process. Get some data points, find the slope. I put it in this form so I don't get sloppy and do something, so I don't do something sloppy. We'll use that word. I put it into this form. I plug a point back in. That spits out my B value, and that is how I get my line. All right. No, I'm not joking. 5 times on the March test. For you who wanted to talk about lines at the beginning, this is the most important line concept as of recent. Know this one. Is there is there any other line concept that you wanted to go over in particular? I noticed this test is actually a little lighter on lines than some of the more recent ones. All right, well, you think it over, and I'll just jump to the next section. So now here we are with the calc. One moment, sorry. All right. So here we have a graph. The graph above shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is closest to the time she finished lunch and continued her hike? All right, so, this is one, it's not going to be, daunting or tricky. So this is just asking, based on the graph, which of the following is closest to the time she finished lunch and continued her hike, right? Well, like, if this is distance from the campsite in miles, right? Well, when does the distance stop? Stops here, right? So this is when she's not moving. She's not getting closer to the campsite or further away from the campsite. So this is when she stopped, and you can see that that's about 140. That's all that's going on there. By the way, does anyone have anything in particular in this section that they would like to go over? No, we just know everything? All right. I look forward to you all getting an 800. The table above shows the distribution of age and gender for 25 people who entered a contest. If a contest winner will be selected at random, what is the probability that they will be either a female under 40 or a male over 40? All right. So this is one of those is over of questions. It's probabilities, but it's an or probability, not an and probability. The reason why or versus and probabilities is if you're doing combined probabilities and it's or, you add them together. If it's and, you would end up multiplying them. That's really more of an ACT thing than an SAT thing. So now what you really need to do, though, pay attention to, though, is the is over of. Of is our total universe of who we're selecting from. Sometimes they'll say if we select a male, what are the odds they will be under 40, right? Well, in that case, we would just be ignoring all the females. The of would be 14. But here it's asking us if a contest winner is selected at random, right? Our of is everyone, right? So now it's saying if they're selected at random, what is the probability the winner will be either a female under age 40, well, there's only 8 females under age 40, or a male 40 or older. Well, there's only 2 males 40 or older, right? So so you can think about this as is over of, or I prefer acceptable over total, right? There is 25 total selections. Of those 25, though, only 10 are acceptable, right? So that is our answer. All right, the graph below shows the number of music album sales in millions each year from 1997 to 2009. So this says 0 through 12, but also 97, 2009. Based on the graph, which of the following best describes the general trend in music album sales from 1997 through 2009? So if we take a look here, right, it goes up and then it goes down. So sales generally increased each year. Nope. They didn't. So sales generally decreased each year. Nope. It goes up and then it goes down. Sales increased until 2000, then generally decreased. Well, 2000 would be here, right? If that's 97, year 3 is 2000. Yeah, that seems fine. And no, they absolutely did not remain steady. So C is our answer. Huzzah. All right, so N of F, right? What's another way you can think about this? XY. And these are ordered pairs. Oh, cool. So this says the following shows some of the values of linear function f. Which of the following defines f? This is asking us to build that line, right? So we can do this that very rigorous way I showed you. You can also do this one, a lot easier because it's kind of simplified. It's not the world's hardest one to do in a little bit more of a freehand way, but this literally is a version of that question we were just talking about, right? These are a bunch of line possibilities. So now the shorthand way of doing it, right? Well, I've defined X and Y. So our slope is our change in Y over at change in X, right? So that would be, so let's take these data points. Well, the shorthand way would just, we see that goes up 3. Then if we count 3 backward, we know this goes up 3, right, per 1. So that would be 3, the slope is 3. And then if we go here to 1 and we count to 0, we would subtract another 3 and we would get to -5. So C is going to be the answer. But like, let's do that in the more rigorous way because shorthanding it only works because this is question 4. So that's a data point. That's a data point, all right? So change in Y over change in X, 4 minus 1 over 3 minus 2, 3 over 1. So our slope is equal to 3. Y is equal to 3x plus b. All right, well, let's take one of those data points, 2, 1. 1 is equal to 3 times 2 plus b. 1 is equal to 6 plus b. B is equal to -5, right? That is literally just that process I described to you. They've been going real hard on it. How would they make this more complicated for a later question? They'd hide the information in a table. They'd hide it in a chart, something along those lines. It'd be a word problem that you need to untangle. But if they're ever just asking you to like build the equation of the line and you have some sort of chart or some sort of table, you get 2 points and you follow the process I showed you. Anyone have any questions on that? All right. At Lincoln High School, approximately 7% of enrolled juniors and 5% of enrolled seniors were inducted to the National Honor Society last year. If there were 562 juniors and 605 seniors, which of the following is closest to the number of total juniors and seniors that were inducted to the Honor Society? All right, so this one's pretty straightforward. All we're doing is, we're going to multiply the percent of juniors and by the number of juniors and the percent of seniors by the number of seniors and add them together. So 0.07 times 652. So it says approximately, by the way, because yeah, the answer you get to that is 39.34. Let's just round that to 39 and leave the 0.34 of a student out of it. So by the way, if you ever see these in math, that is the about equal to sign. All right, now 0.05 times 602. That is about equal to 30. So 69. We just add them together, and then that'll give us that combined thing. Yep. All right, moving right along. Which of the following is the sum of the 2 polynomial functions shown above? All right, all we're going to do here is we are just going to add those. So if we add them together, we'll get 8x squared minus 7x minus 4. Cool. Now, interestingly enough, this is not that like subtracting them is hard, but if you subtract them, that's where people get tricked more, because you have to remember to flip the signs on all of them. right? If we were subtracting, we would have to remember to add both of those because the sign gets flipped. Also, like the confusing way of seeing this is when they would do, confusing might not be the right word. The trickier way would be if they did this, because people rampantly forget that they have to distribute it to all of these. So you end up subtracting 5x squared and then adding 2x and adding 6. All right. So for 6, though, our answer is A. All right. Hold on one moment. I'll be right back. Okay. If 3/5 W is equal to 4/3, what is the value of W? All right, so this is just pretty straightforward algebra, right? So all we need to do is cross multiply. Not even cross multiply. All we need to do is clear the coefficient on the W. Right? Okay, how do we clear 3/5? We just multiply both sides by 5/3. Those cancel. W is equal to 26ths, which reduces to 10/3. Nope, sorry, 29ths. Bad tutor. 29ths. So the answer there is D. Hooray. All right, the average number of, does anyone have any questions on anything so far? The average number of students per classroom at Central High School from 2000 to 2010 can be modeled by the equation y is equal to 0.56s plus 27.2, where x is years and y is the average number of students per classroom, right? So how do I like to think about that? 0.56 is the increase in students per classroom per year. That's how I like to think about that. And 27.2 is the average number of students per classroom in the year 2000. That's how I like to conceptualize those. I find it how it works the best. So now, which of the following best describes the meaning of 0.56? Okay, well, 0.56 is the increase in students per classroom per year, right? It's not the total number of students. It's not the average number of students. It is the estimated increase in the average number of students class per year, exactly what we said. We are done here. Hooray. It's almost like I know what I'm talking about. All right. Nate walks 25 meters in 13.7 seconds. If he walks at the same rate, which of the following is closest to the distance he'll walk in 4 minutes? All right, so the only thing we have really going on here is we have this conversion from seconds to minutes. So that's just what we need to be mindful of. We're shifting from one unit to the other. So so now we can actually do this kind of by approximation, given that none of these numbers are close to each other, right? So we know he's walking 25 meters in 13.7 seconds. Let's just call that 25 meters in 15 seconds, because we know 15 seconds is a quarter of a minute, right? So he's walking 25 in a quarter of a minute, right? So how many quarters of minutes are there in 4 minutes? 16. So if we do 25 times 16, all right, if we do 25 times 16, we get 400. Now, it's not at 450 because we approximated, but the answer there is going to be 450. If we had done that, you can do that more rigorously with like, a very strict unit conversion. But the reason why I knew we just kind of we didn't need to go that intense was those are nowhere near close to each other. If they had been closer, you can't just use that shortcut. you'd have to actually do like some more intense unit conversion. But basically, like, even if we were trying to do it that way, that would be 13.7 seconds. And if we want to figure out how many minutes that is, well, okay, well, it's 1 minute per 60 seconds, right? The seconds cancel. So the speed we had was, he was going 25 meters per, and then this would be 13.7 divided by 60. Which is, about equal to 0.23 minutes. So it would be 25 meters per 0.23 minutes. Which is 108 meters per minute. 108 meters per minute times 4 minutes is, that's going to be, again, approximately equal to 450. That's the more structured way of doing it, where you're paying very close attention. You will need to do that on the harder ones, where you're paying like pretty close attention to where your units are and actually working through the math. But since this is an earlier one, it's much more, hackable, we'll call it. Does anyone have any questions? Okay. What is the weight in newtons of an object on Mercury with a mass of 90 kilograms? All right, so, well, this is based on all of this. So let's take a look at this. All right, the weight of an object on a given planet can be found using the formula weight is equal to mass times gravity, where W is the weight and M is the mass and G is the gravity, is the acceleration due to gravity measured in meters per second squared. What is the weight of something? 90 kilograms. All right, so, well, it's asking us what the weight. Well, we know weight is equal to mass times the acceleration due to the force of gravity. It told us the weight. It told us the mass, 90 kilograms. Is this in kilograms? Yes, the mass in kilograms. That is something, if they're trying to get tricky, they could do to you. Like, they could give you the mass in kilograms here, but it's the mass in grams there. By the way, your conversion, milligram, there's 1,000 milligrams to a gram, and there's 1,000 grams to a kilogram. They do just kind of expect you to know that sometimes, so please do. And now, though, it's asking the weight of an object on Mercury, right? Well, if we look at the table, okay, well, that is where we can get the acceleration due to the force of gravity for Mercury. So it's 90 times 3.6 is equal to the weight. 90 times 3.6, 324. Boom. An object on Earth has a weight of 150 newtons. On which planet would the same object have an approximate weight of 170 newtons? Okay, so here's what we kind of have. Here's what we need to do here. Right, so here's our, our acceleration due to the force of gravity. What we need to do here is we need to take this weight and find out what the mass of the object is. And then we can check what the mass of the object, what the weight of the object would be with each of those coefficients due to the force of gravity. Is this one susceptible to being cheated? Only a little bit. We know it's either, I'll show you in a second. You can narrow it down to 2 without really doing anything, but they're close enough that you can't really finish the problem that way. All right, so the weight of an object on Earth is 150 newtons. 150 is equal to acceleration due to the force of gravity on Earth, 9.8 times mass, right? So if we did that division, 150 divided by 9.8 is 15.31. All right, so the mass of the object is 15.31 kilograms, right? Now, it's telling us that the weight is going to be 170 newtons on the new place, right? Now, we could literally just start multiplying our way through, but what does that mean if it's going up? That means, and it's only going up a little, that means that the acceleration due to the force of gravity on wherever it's going is going to be like slightly higher. And this is why I was saying you could actually like cheat a little bit and knock it down to 2. Well, if we take a look here, right? We take a look here. If we take a look at Venus, right? Well, Venus would be lighter. That's lower than 9.8. And Neptune would be a lot higher because it's 14.1. So we know it's either going to be Saturn or Uranus. It's going to be one of the two. And now we can just multiply that 15.31 by 11 or that 15.31 by 10.7 and see which one spits out 170. So let's try it with Saturn. 15.31 times 11.1 is 169.94. So that is the answer. It's 169.94. We're not getting closer with the other one. So our answer is B. All right. So does anyone have any questions on anything we've done so far or have a particular question they would like to go over? All right, moving right along. 12. If the function f has 5 distinct zeros. So what does that mean? If we're talking about a polynomial, a 0 is where, if we're talking about one equation, not a system of equations, if we're talking about one equation, a 0 is where it crosses the x-axis. Actually, if we're talking about a system, that doesn't make any sense in the context of a system for reasons I will not get into. But for this, if it's asking us where the zeros are, all we need to know is that what zeros mean is where does it hit the x-axis, right? Rather, how many times does it hit the x-axis? So it's asking which of the following could represent the graph. Well, if it has 5 zeros, we need to find the one that hits it 5 times. 1, 2, 3, not our answer. 1, 2, 3, 4, not our answer. 1, 2, 3, 4, 5, 6, not our answer. 1, 2, 3, 4, 5. D is our answer. It's that straightforward. All this question is really is testing is, do you know what a 0 is? All right. So the equation above gives the height h in feet of a ball t seconds after it's thrown straight up with an initial speed of v feet per second from a height of k feet. Which of the following gives v in terms of h, t, and k? All right, so this is asking us which gives us v in terms of h, t, and k. This is literally just asking us to solve for v. I mean, if you look down here, it's that. Now, all of you know how to do this. Where you guys tend to get thrown is just because there's so many variables. But like, I guarantee you pretty much every single one of you, if I had narrowed it down where the only variable was like t, you guys would be able to do it in a second. But here's what you would do, right? All we're trying to do is get v by itself, right? Well, so, all right, so we have h is equal to negative 16t squared plus vt plus k, all right? All right, well, so if we're trying to get v by itself, the first thing I would do is I would add 16t squared and subtract k. So then we would have h plus 16t squared minus k is equal to vt. Cool. And then I just divide by t. All right. So this is what we would end up with. Now, why isn't there one that looks like that exactly? It's because they decided they wanted to display it in a little bit of a weird manner. So instead of having this, what they did is they simplified this term. So what they did in effect was make it h plus k over t plus 16t squared over t, and they canceled out that t on the bottom with the squared. So you got h plus k over t plus 16t. Oops, sorry, h minus k over t plus 16 times t, plus 16t, which is d. Anyone have any questions? All right. The cost of using a telephone in a hotel meeting room is 20 cents a minute. Which of the following equations represents the total cost in C dollars for hours of use of the cell phone? All right, so we can just hack this problem. Because like this is very straightforward to conceptualize. Like I would even recommend just doing it this way, which is, all right, so the cost of using a telephone is 20 cents per minute. Which of the following represents the cost per hours of use, right? So let's say we do this for exactly 1 hour, right? So we know 1 hour is 60 minutes. So we know the cost if we did that. So 1 hour, right? 1 hour, we know 1 hour is 60 minutes. So if we use this for 1 hour, that would be 60 times 0.2, 0.02, nope, 0.2. So we know if we did it for an hour, we would get 60 times 0.2. The phone call would cost $12. Right? Well, that would be minutes, that's cost, that's dollars, and we also know that that is 1 hour. We can just go to this and see which one when we plug those in would work, right? Oh, conveniently, this first one, if we take a look at A, all right, well, if we plugged in 1 for that, well, then we're right back to 60 times 0.2, $12. A is the answer. Does everyone follow what I just did? All right. So by the way, another way we can kind of do some things here as well. We know it didn't say there was an initial cost, so that's gone. And these don't make a lot of sense, but the best way of doing it is probably just the way I did it, where I was just making up numbers. Another way you could do this is through rigorous application of unit conversion. I don't recommend that because it's wildly unnecessary for this one. All right. So in order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Half of the participants were randomly assigned to receive treatment X, and the other half did not receive treatment X. All right, so we're doing a study where we're controlling our variables. The resulting data showed that participants who received treatment X had significantly improved eyesight as compared to those who did not receive treatment X. Based on the results of the study, which of the following is an appropriate conclusion? All right, so this seems like this is a pretty, solidly done study. They picked people with poor eyesight at random, and of people with poor eyesight, and right now, right, this can only work, this a conclusion only applies to people with poor eyesight. We can't generalize it to people who already have good eyesight. But of the people with poor eyesight, they improved more than the group that didn't get it. So let's see. Treatment X is likely to improve the eyesight of people who have poor eyesight. Yeah, that seems fine. Treatment X improves the eyesight better than all other available treatments. Well, we didn't talk about any other available treatment, so we cannot say that. Treatment X will improve the eyesight of anyone who takes it. See, that might be tempting, but first of all, anyone is way too strong, but we can't even say it's likely to improve the eyesight of anyone. And that would actually be this one, will cause a substantial improvement. Well, one, it did say it significantly improved the eyesight, but again, the group, we're only allowed to apply this conclusion to the group we studied. And the group we studied was people with bad eyesight. So we can only apply it there. These would imply, well, this one implies like everyone, but both of those aren't specific to just that group of people that we actually sampled from. So our answer there is A. Questions, anyone? Comments, concerns, criticisms, rebukes, rebuttals? Okay, no one has any question in particular they would like to go over? All right. Graph of functions f and g are shown in the xy plane above. For which of the following values does f of x plus g of x equal 0? All right, so what is another way of saying f of x and g of x? This is y for a given x and g for the same x, right? So the only thing, like, this question is just a little confusing to understand what it means, but basically what this question is asking is for what value of x would we add the y's and get 0? These values, right? This is +2, this is -2, and it is at -1, 2, right? So for what value of x? Well, when x is -2, g of x is +2, f of x is -2. So for x is equal to -2, the y values add to 0. That's what's going on there. It's confusingly asked. All right, we're just going to skip, unless anyone has a burning desire for those, we're going to skip over those and keep going. All right. Graphene, which is used in the manufacture of integrated circuits, is so thin that a sheet weighing 1 ounce can cover up to 7 football fields. If a football field has an area of 1 1/3 acres, how many acres could 48 ounces of graphene cover? All right. So 1 ounce can do 7 football fields, and each football field has an area of that, right? So 1 ounce to 7 football fields. All right. So 7 football fields would have, all right, so I'm just going to convert that to a fraction. So that would be 28 thirds. All right, so basically, actually, is that the best way of doing it? Yeah, all right, so we have 28 thirds. It would be 28, so we have 28 thirds acres per ounce, right? Because it's 7 football fields, and if each football field is 1 1/3 acres, that's what's going on there. So now it says how many acres could 48 ounces of graphene cover? So yeah, so now this is how many acres we're dealing with, right? But more specifically, that is how many acres for 1 ounce. So divided by 1 ounce. So what we have is we have 28 over 3 acres per ounce, right? Now, well, it's telling us how many acres could it cover with 48 ounces times 48 ounces. The ounces cancel and we're left with acres. And when we actually multiply those, what we end up with is, well, we end up with 448, but that's because we're rounding. So the answer is 450. Huzzah. Michael swam 2,000 yards on each of 18 days. The scatter plot shows his swim time for and corresponding heart rate for each swim. The line of best fit is also shown. For a swim that took 34 minutes, Michael's actual heart rate was how many beats less than the rate predicted by the line of best fit. So this is just one of those scatter plot problems. Now, one thing you want to remember with these is the data points are real. The line is the prediction, right? So if this is asking what is the difference between the data point and the line, right? So for a swim that took 34 minutes, so that is this line, his actual heart rate was how many beats less than the prediction, right? Well, our prediction was 150 and our actual was over here, right? So now what does each one of these boxes represent? Well, there's 1, 2, 3, 4, 5. So each one of them represents 2, right? So that's 150, that's 148. Our answer here is B, 2, right? Of the 4 types of savings account, which one would yield exponential growth? Oh, I don't know if we've actually talked about exponential growth. Just a real quick rundown on exponential growth equations. Here's how I like to conceptualize them. You know, I'm big on conceptualizing things as words. It's what works for me. I find it's what works for my students, particularly the ones who like aren't, you know, they don't think in math, they think in English. So here's the exponential growth equation. The new amount is going to be equal to the original amount times 1 plus or minus the percent change, right? And what do I mean by that? Well, if it increased by 2%, it would be 1 plus 0.02, right? If it decreased by 10%, it would be 1 minus 0.1. And then that is raised to the compounding period. So what do I mean by compounding period? Well, let's say it compounds yearly. Well, if it's 3 years, a 3 would go there, right? Now, by the way, there is a genre of questions where they're going to give you like weird units, right? If you ever end up with like, let's say this is our equation, right? So y is equal to, you know, 4 times 1.02 raised to the, all right, now let's say this is m divided by 12. The only way you end up with a fraction here is if the time amount they're giving you in the question is different than the compounding period. Now, I picked m over 12 consciously because this is one you'll actually see. Let's say it compounds yearly, but they give you months, right? All right, so this compounds once a year, but it's asking you how much will it grow in 5 months, right? Well, that's when you would get m over 12, and if you know if it was 5 months, m would be equal to 5, so it would be raised to the 5/12. Is that clear to everyone? Okay, so just remember the trick with that is the trick with this particular one is when if you see a disagreement in units, if you see like some sort of weird unit here, what's going on is that compounding period, the amount of time it takes to compound once is not the same as the amount of time they gave you. But now let's take a look at the actual question. Of the following 4 types of savings account plans, which of the following would yield exponential growth of the money in the account? Each year, 2% of the initial savings is added. No, 2% of the initial savings is not compounding. Compounding is when the growth, it's like compounding is when the growth, the percent growth is applied to the amount that you grew the previous year, right? So it's basically, you know, it's increasing, you know, 1 becomes 1.1, becomes 1.21, because when you multiply that, you know, so on and so forth. Basically, it's when the modification, the percent increase is applied to the new amount, not the original amount. Each successive year, 1.5% of the initial savings and $100. Nope. That would just be adding the same amount every year. Each successive year, 1% of the current value. That's exponential. Every year, the current value grows by 1. So that means as more money is in the account, more money is generated. By the way, this is why people can retire each year, but also each successive year, $100. No, that would just be a line. I mean, all of those would just be lines. By the way, this is why people can, in fact, retire. It's the miracle of compound interest. Roughly, if you invest in the stock market, like roughly every 7 years your money doubles. So and the doublings get really big at the end. So actually, like, I trust me, if you invest $1,000 like when you're like 20, you just get this like wildly dramatic increase in the amount of money when you retire, as opposed to if you started investing at like 30 or 40. It's like, you know, it's in the factor, it's like $128,000 more or something like that. All right, let's find a good one. All right. A grain silo is built from 2 rectangular cylindrical cones and a right circular cylinder with the initial measurements represented in the figure above. Of the following, which is closest to the volume of the grain silo in cubic feet? So this is one of those like, oh, we have a weird shape. What do we do? Let's just break it down into shapes we're familiar with. We have 2 cones and we have a cylinder. Now, you should have the cylinder memorized. Like, you don't need to because it's in the equations, but like, you really want to have the cylinder memorized. The cylinder is just pi r squared h, which is still actually just base times height. It's just our base is a circle, right? Now, the cones, you do not need to have the cones memorized, but they too are at the beginning of the section. So that is 1/3 pi r squared h. Right? So 1/3 pi r squared h, right? And then, so what do we know? Well, we know we have 2 cones and the regular cylinder, right? So we can just run those numbers. Pi r squared h, well, r is 5 feet, and the height for that is 10. So this is going to be pi times 5 squared times 10, also known as 250 pi. And then we have the cones. Now the cones are, so the cone is going to be, it's going to be 1/3 pi. Now r there is still 5. So we'll just go straight to 25 for the purpose of simplicity, times 5. So that is going to be 125 divided by 3 times pi, right? And we're going to have 2 of those. So 250 divided by 3 pi. So now we just add that to 250. 250 pi. So that'll, when you add those together, you get approximately this, which conveniently is our answer. Yeah, this is like roughly 750, and this is roughly 260, and that's closest to that. All right, so that is our lesson. It's been a pleasure, and I will see you guys next week.
Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.